Friends, welcome to my channel. Dhanesh here.
We will develop a text filler using Ngrams. An Ngram is a connected string of n items from a sample of text or speech. The Ngram could be comprised of large blocks of words or smaller sets of syllables. Ngrams are used as the basis for functioning Ngram models, which are instrumental in natural language processing (NLP) as a way of predicting upcoming text or speech. There are different Ngram models. As mentioned, Ngram models are used to aid in prediction of speech and or text. They utilize the stochastic properties of Ngrams and sometimes incorporate elements of the Markov model. Ngram models and the algorithms that use them benefit from their relative simplicity and scalability, enabling smaller experiments to scale up from larger n sets. How does an Ngram model work? Ngram model works by taking a sequence of items and predicting upcoming items. For example, imagine a string of letters used for DNA sequencing. An Ngram model will analyze the sequence of letters and, utilizing training data, creates a probability distribution for the likelihood of upcoming values. Each possible values will be assigned a probability, and the sum total of all possibilities will be 1. There are different applications of Ngrams. There are different applications for Ngrams, from predictions in DNA sequencing to implementation for better text prediction with neural networks. Ngram models have a wide range of applicability. Language identification is another application of Ngram. Ngram models are used in natural language processing as a tool for modeling probable upcoming sequence of characters, also known as trigrams or 3grams. Another application is information retrieval. The predictive power of Ngrams is applicable in modern search algorithms. For example, Ngram models are applied to database of documents, and given a single query for a document is able to provide a sequence of similar documents. Using reference documents as training data, Ngram model assists in providing relevant additional resources in a search function. Automatic text filler is a very useful application and is widely used by Google and different smartphones, where a user enters some text and the remaining text is automatically populated or suggested by the application. See, what is the problem with TF-IDF and bag of words approach? Before we go and actually implement the Ngram model, let's first discuss the drawback of the bag of words and TF-IDF approaches. In the bag of words and TF-IDF approach, words are treated individually and every single word is converted into its numeric counterpart. The context information of the word is not retained. Consider two sentences. Big red machine and carpet and big red carpet and machine. If you use a bag of words approach, you will get the same vectors for these two sentences. However, we can clearly see that in the first sentence we are talking about a big red machine, while the second sentence contains information about the big red carpet. Hence, the context information is very important. The Ngram model basically helps us to capture the context information. What is the theory behind this Ngrams model? See, Wikipedia defines an Ngram as a contiguous sequence of n items from a given sample of text or speech. Here, an item can be a character, a word, or a sentence, and n can be any integer. When n is 2, we call the sequence a bigram. Similarly, a sequence of 3 items is called a trigram, and so on. In order to understand Ngram's model, we will try to understand the Markov chains work, how it works. We already discussed about the Markov chain. See, connection of Ngrams and connection of Ngrams with Markov chains. As you are aware, as we discussed, a Markov chain is a sequence of states. Consider a Markov system with two states, x and y. In a Markov chain, you can either stay at one state or move to the other state. In our examples, our state have the following behavior. The probability of moving from x to y is 50%, and similarly the probability of staying at x is 50%. Likewise, the probability of staying at y is 50%, while the possibility of moving back to x is also 50%. This way, a Markov sequence can be generated such as x, x, y, x, etc. In an Ngrams model, an item in a sequence can be treated as a Markov state. Let's see a simple, example of character bigrams where each character is a Markov state. Let's have this sentence. Football is a very famous game. The character bigrams for the above sentence will be FO, OO, OT, TB, BA, AL, LL, L, I, Is, and so on. You can see that bigrams are basically a sequence of two consecutively occurring characters. Similarly, the trigrams are sequence of 3 contiguous characters like foo, FOO, OOT, OTB, TBA, and so on. In the above 2 examples we discussed, we saw character bigrams and trigrams. We can also have bigrams and trigrams of words. See, as discussed, our previous example, big red machine and carpet, the bigrams of this sentence will be big red machine, and carpet. Similarly, the bigrams for the sentence big red carpet and machine will be big red carpet and machine. Here in this case with bigrams, we get a different vector representation for both of the sentences. See, in the coming example, we will implement the Ngram model from scratch in Python, and we will see how we can create automatic text filler using Ngrams. There are different types of Ngram models, character Ngram model and words Ngram model. In this video, I will be developing a character Ngram model, and in the next video, I will be coming up with an implementation for words Ngram model. So, in the current video, in this video, let's focus on the character Ngram model development. To create our corpus, we will scrap the Wikipedia article on tennis. Let's first import the libraries that we need to download and parse the Wikipedia article. I have imported NLTK, NumPy, random, regular expressions, RE. It's working fine. I run it. We will be using the Beautiful Soup 4 library to parse the data from Wikipedia. Furthermore, Python's regular expression library RE will be used for some pre-processing tasks on the text. If you are familiar with the NLP life cycle, you may be familiar with the pre-processing tasks on the text. See, as discussed, we will use a Wikipedia article on tennis to create our corpus. The following, the next script I'm going to write retrieves the Wikipedia article and extracts all the paragraphs from the article text. After that, the text is converted into lowercase for easier processing. Let me write the script for. You can see the script here and it's working fine. Next, we remove everything from our data set except letters, periods and spaces. Let me do that. Let me run this. Yeah, fine. We have processed our data set and now it's time to create an Ngram model. We will be creating a character trigram model. Let me run this. Yeah, you can see it here. You can see the output here. It is see, it's there. It's going. It's a output. You can see it here. This is the script. This is the script I have written. Now, if you see in this script, all right, we create a dictionary in Ngram. The keys of this dictionary will be the character trigrams in our corpus, and the values will be the character that occur next to the trigrams. Next, since we are creating Ngram of 3 characters, we declare a variable chars. After that, we iterate through all the characters in our corpus, starting from the 4th character. Next, inside the loop, we extract the trigram by filtering the next 3 characters. The trigram is stored in the sequence variable. We then check if the trigram exists in the dictionary. If it doesn't exist in the Ngrams dictionary, we add the trigram to the dictionary. After that, we assign an empty list as the value to the trigram. Finally, the characters that exist after the trigram is appended as a value to the list. If you open the dictionary Ngrams, in the spider variable explorer, you should see the output. It should be better, but here I am using the Jupyter notebook. You can see trigrams as keys and the corresponding characters which occur after the trigrams in the text as value. You might see keys with 2 characters in the dictionary, but they are actually not 2 characters. The 3rd character is actually a space. Let's now try to generate text using the first three characters of our corpus as input. The first three characters of our corpus are 10. Let's write the script. Let me run this. You can see the output here. 10 is a racket. See, you can see the output. So as discussed previously, let's now try to generate text using the first three characters of our corpus as input. The first three characters of our corpus are 10. Look at the output, then you can see it here. So let me write this. This is the script I have written. So in the script, we first store the first trigram, that is 10, into the current sequence variable. We will generate a text of 200 characters. Therefore, we initialize a loop that iterates for 200 times. During each iteration, we check if the current underscore sequence or the trigram is in the Ngrams dictionary. If the trigram is not found in the Ngrams dictionary, we simply break out of the loop. Next, the current underscore sequence trigram is passed as key to the Ngrams dictionary, which returns the list of possible next characters. From the list of possible next characters, an index is chosen randomly, which is passed to the possible underscore chars list to get the next character for the current trigram. The next character is then appended to the output variable that contains the final output. Finally, the current underscore sequence is updated with the next trigram from the text corpus. If you print the output variable that contains 200 characters generated automatically, you should see something like this. We will run this. See, then it says short to start a point. The server then moves to the other side of the body. Forehands and backhands may be. See, you can see the output here. The output doesn't make much sense here in this case. If you increase the value of the chars variable to 4, you should see the result similar with more accuracy, and you can see that the results are a bit better than when we got using 3 grams. Our text suggestions filling will continue to improve with the increase the Ngram number. Thanks for watching. Please like, share and subscribe. Thanks a lot.